Okay, 8th grade. We're going to go through lesson 7.2. And this lesson is on using the substitution method to solve a system of equations. Remember last time we used the graphing method. Remember where you would graph and where the lines cross, you get a point that makes both equations true when you put in the numbers. When you put in the x value and the y value in each equation, it makes them both true. So that's one way to solve a system of equations, or to find the point that makes them both true. Another method is called the substitution method. Okay? So this is just a method that you can use without graphing. Alright? So, in this method, what you're going to do is you're going to eliminate having to use two variables, because you can't solve for two variables at the same time, can you? You can only solve for one. So, instead of using y, for example, we're going to use whatever y equals in the equation. Now, sometimes you might not know what y equals. And so the first thing you may have to do is solve for y. But in both of these equations, we know what y equals. So we can just take what y equals x plus 7, and we're going to put that on this side in place of y. We're going to replace the y in the other equation with the expression for y. So the expression is x plus 7, and then that equals negative 4x plus 8. Does everybody see that? We took this part, the right side, and we kept that the same. And then instead of the y, we wrote what the y equals on this side. Does that make sense? You following me so far?
So far?
Yes.
Yes.
Okay. Now you can solve for x. I'm going to move this out of the way. Okay. We can solve this for x now, can't we? We can get the x by itself on one side. How can we do that? How would we get the x by itself?
Add negative x to both sides. Or,
Okay.
I mean, not the x by itself, I meant add negative 7 to both sides.
So if we get rid of the 7, then this x will be by itself, right? That's your thinking?
I guess, or you could do that.
And add
Or you could
negative
do that.
7.
Or you could add
Right.
negative x to both sides, so then x would be technically alone, right? Because it'd be negative 4 and negative 5x.
Well, we have two x terms,
Wait, never
one
mind,
on each
never
side.
mind. Never mind.
I think you're getting ahead of yourself,
Yeah,
though.
I am.
Look, let's just go through this. Alright, so far, we have x by itself, and that equals negative 4x plus 1, right? Ready? You with me? Now, we still don't have all the x terms by themselves. We have an x term on both sides. We have to get rid of the x term on one of the sides.
Add 4 to both sides.
Add 4
X.
x to this side, and add 4x to this side. You with me? How many x's do we have now?
5.
5x. And that equals what?
1.
1.
And then divide by 5.
Divide by 5. And we learn what x is. X is 1/5. Right? Now,
Nice.
since we know what x is, we can find what y is.
Wait, how many do you count with bias?
We don't know what y is yet.
So y equals negative 4x plus 8.
Right, but what's the number?
Oh,
So then you
Negative-
use the
negative 4
substitution
times
method again.
1/5 plus 8.
Right, so now we use this number for x. Now, we can put this into either equation. We had x plus 7, and we had negative 4x plus 8.
So you add.
So the other equation was y equals x plus 7, right? Would you rather replace the x in this equation, class, or in this one? Isn't this a more simple?
Yeah, because you
Equation?
add 1/5 to 7, then
Yeah.
it just equals 6 and
So then we just put 1/5 plus 7.
which equals y equals 6 and 1/5. No wait,
Y
I'm sorry.
equals
Y equals 7 and 1/5.
7 and 1/5,
I was thinking 1/5 was negative.
right? So now, what is the solution? In other words, what are the points?
short yesterday.
What are the points?
It would be
What's the x and y coordinates?
7.
What did we
7
find?
and 1/5 and 1/5.
Which one is which?
7 and 1/5 is like the y, and then x is 1/5,
So it's 1/5,
comma 7.
or you could write it as 0.2, and this is
7 and 1.
7 and 1/5,
7.2.
or 7.2. Any questions on what we're doing? The basic procedure is to find what one of the variable is equal to in one of the equations, so that you have an expression for that variable, and then you can put it back into one of the equations to find what that variable equals. Look up here. Okay? And then put that number in place of it, in its place in the other equation, so that you can find what the other variable equals. If you know what the x equals, then you can replace that number with x in the other equation.
So like in the book,
Find
does it
y.
give you 2 problems?
It'll give you 2 equations, yeah. I just did example 1 on page 382. Okay? That was example 1. Let's do example 2 quickly. So here's another set of equations. 3y plus 2x equals 4. And
Maybe use another piece of paper.
negative 6x
The people in Africa will be very
plus
mad at
y. Pay attention, Will. Write these down. Equals negative 7. Are either of them solved for a variable?
you.
What's the first thing we have to do?
Get y on its own side.
We have to solve for one of the variables. We have to find what one of the expressions is. So go ahead and do that.
Oh, wait,
Wait, what?
okay.
I mean, I wasn't.
You have to solve for one of the variables.
To get y?
To get y by itself or get x by itself in one of the equations. So let's say we have, get rid of the 6x on this side and add it to this side. So then y equals 6x plus negative 7. Right? Then we can take this expression and put it over here in place of y. Okay? So 3
Times 6x.
3 times
6x.
6x plus negative 7 plus 2x equals 4.
this,
Lot
it
of
makes
work.
sense, but I don't know why.
Well, now we have just one variable, we can solve for that variable. We have to distribute the 3. So 18x plus
Negative 21.
-21 plus 2x equals 4. Combine like terms, good. 20x plus -21 equals 4.
Oh, add 21.
Good, add 21 to both sides.
Ooh,
And then you get 20x equals 25.
Yep, 20x equals 25.
And then you divide by 20.
Yep,
And then you get x equals 1 1/5.
good.
Or
X equals 1 1/5, or since that's a
or
nice
1.2.
1.2, might be easier to work with.
okay.
And then put that in for x.
So 1.25 and 0.5.
So we could put it back in here.
Yeah.
What?
These are smaller numbers to work with. So, now let's take this and put it in for x. Look up here. Take the 1.2 and put it in for x. And leave the y, so now you can find the y value. Or, we could put it in for this x and find y. Okay? Six times 1.2 plus -7, you can just put that into a calculator.
So you go 7.
7.2, right?
That's the same answer, please.
Right?
Is that right?
7.2.
No.
No,
No, -6 times 1.25. So that's in the book.
6 times 1.2.
It said 1.25 in the example.
Oh,
Brady, don't be cheating under the
Yeah,
example.
it was 1/4.
oh, Brady, it's 1/4, isn't it?
Yep, it all comes back to
It's
Brady.
5/20, which is 1/4 instead of 1/5.
I still said 25/20.
I was thinking 1/4. but then
Yeah.
I just
Yeah.
Brady said it would be right, so I just went along with it.
Why would you trust Brady?
1 and
Well,
5/20, which is
It's Crosby's.
1 and 1.25.
Mine too.
Okay, so now,
So
What-
6 times 1.25
Yep.
plus y equals -7.
plus y equals -7.
Then you do -7.5 plus y equals -7.
Yep.
Which is -7.5 and 05 minus 7.5, and you get y equals 0.5.
Y equals
I
0.
just want to know how cute Crosby.
And yeah,
Okay,
I'm just copying off my notes.
correct?
Yep.
Yeah.
So what's our solution? What do you have to write for your solution, your actual answer? You can't leave it this way.
Y equals. Oh wait. Ooh. Okay, 1.25 comma 0.5.
Correct.
Why'd you call me Tarzan?
Okay? All right,
Okay.
there's the substitution method for you.